Hello everybody, this is Math 140 Day 13. I've looked at Alex, and after we've done functions and we've done circles and line segments, distance, we need to talk about inequalities. There's no less than 5 types of absolute value inequalities in this module. So I'm going to talk about examples for all 5 types. What we need is some tools to deal with inequalities, not just absolute value inequalities. So, so here's the tools that we can use on inequalities. First, we can add or subtract the same quantity from both sides, to both sides, or subtract from both sides. Goes without saying it's the same quantity, okay, on both sides. This would happen outside any absolute value that is happening anywhere in there. Outside any absolute value. Next tool at our disposal is multiply or divide both sides by a positive number. A number that's greater than 0. This is also possible inside the absolute value. Third tool. Shift the variable left or right. And the last one, which is not strictly needed for these problems, but it just belongs here, is multiply or divide both sides by a negative number. A number that's less than 0. But if we do that, then we have to reverse the inequality. Reverse the inequality. So if it's less than, then it becomes greater than, and vice versa. If it's less or equal, it becomes greater or equal, and vice versa. And what happens with an absolute value, if you pull out a negative number out of the absolute value, just one tiny example, absolute value of negative 3x is the absolute value of negative 3, which is positive 3 times the absolute value of x. So that's 3 times the absolute value of x. That's what happens with negative numbers when we try to pull those out of an absolute value. All right, how many tools have we got? We really need only the first 3 here. And now let's attack some examples. For absolute value inequalities. Type 1, the simplest type. Absolute value of v is less or equal to 5. That's all the numbers between -5 and 5. So, right, as compound inequality, you would write -5 less or equal v less or equal 5. A chain of inequalities, 2 inequalities in a row, they have to point in the same direction to make sense. So the v is in between -5 and 5. Also nice, right as interval. It's a closed interval from -5 to 5. Closed means the endpoints are included. That corresponds to the less or equal sign at the beginning that allows v equal to 5 or v equal to -5. And the last bit as a graph. It goes from -5 to 5 on the number line, and all numbers in between are allowed. So we make nice filled in dots to indicate that the endpoints are included, and then we got to make it clear we want this in between. Color would be good too. Okay, no tools needed. This is the basic type of an absolute value inequality. But now what can we do? We do type 2, absolute value of w plus 15 less than 24. What's the toolbox say? We can subtract 15 from both sides. So first tool says -15, -15 both sides, gives me absolute value of w. W is less than 9. And I'm back home in type 1, all right? So I'm not going to do that. We can write this with a compound inequality, write as an interval, write as a graph. You got to read the question, what it actually asks. But once we're in type 1, we're home, we're happy. Type 3, absolute value of y plus 2 less or equal 3. Here we need the shift. Where's the shift? Is tool item 3. Shift the variable left or right. And in this case, it's best to think about this graphically. I recommend to think about this graphically. when y is -2, then y plus 2 is 0. And then the inequality is true, so y is equal to -2 is included. And then y can stray to left or right from that number -2. And how far? 3 units. So the number line, I've got my -2, 3 units to the right, I get to 5, 1. 3 units to the left, I get to -5. Endpoints are included because of the less or equal sign. And that's my answer, the entire interval between -5 and 1. Yeah, right at an interval, you'd get intervals, closed interval from -5 to 1. In terms of a shift, if you want to really use that as a technique, you could introduce a new variable, z equal to y plus 2. So then you're looking at the absolute value of z is less than 3. Less or equal to 3. Done that before, that's type 1. And it gives you all the z values from -3 to 3. In a different color. The z itself could be green. But then y values, that is z minus 2. Every single y value, you grab a z value and subtract 2 from it, which shifts everything. So you go down to the -5 and from the 3 down to 1. 2 units to the left. So that is a technique that helps oftentimes when you shift your variables and introduce a new variable that's equal to the old variable plus a constant or minus a constant, and solve that new problem, which is hopefully easier, and then shift the answers so you get the solutions for the old, harder problem. So that's the shift. And it was type 3, an inequality of type 3. Type 4. Oh. Type 4. That is the same numbering that Alex uses for their topics. Okay, so you'll see exactly this type of problem in homework. Absolute value of 6v plus 6. Absolute value of that less than, strictly less than 12. Here we need two tools. One of the tools divide both sides by a positive number, namely 6. So you can write this as 1/6 times 6v plus 6 absolute value less than 1/6 times 12, or 12 over 6, that's a 2. And now we can pull that 1/6 inside the absolute value. So we get v plus 1. It's best to really do that cancellation immediately in one go and not clutter the page, okay? So the general formula would be with a positive number a times absolute value of something we can pull that inside. In my case, the a is 1/6, and the b is the 6v, and the c is the 6. And then, of course, you have to distribute that number, 1/6, over the sum, which I did. All right. So where am I at? I am at absolute value of v plus 1 is less than, strictly less than 2. And we're back at an inequality of type 3. How did you solve that again? Shift. W is v plus 1. So we're looking at W absolute value less than 2, which is numbers from -2 to 2. That's the W's. And then the V is W minus 1. And therefore you take that answer, the green answer, and you shift it 1 unit to the left. The V values would go from -3 to 1. And this time the endpoints are not included because it's strict inequality. And then we mark that with a nice hollow circle. That is hollow, that is hollow. It's possible with other inequalities that you only have one endpoint included, but with absolute value, it will always be both in or both out. Okay, so that's type 4. And then the last finishing touch to the whole thing is combine all the techniques and tools that you have, and you get type 5 inequalities. I can circle that type 4, yes, type 5. Throw everything that you got at it. 6v plus 6 minus 2 strictly less than 10. Okay, what do we need to do? First step, I would add 2 to both sides. The first tool you want to go slow and careful, write it down like this to both sides. So now we got 6v plus 6 absolute value less than 12, which is exactly the previous example. So if you hadn't seen that previous example, you would start now, divide by 6 and shift. All right, with those tools, you should be able to solve all the absolute value inequalities, all 5 types, and it's really useful. They are happening all the time. Okie doke. I would still mention that thing, what happens if we divide both sides of an inequality by a negative number? Some simple examples. Absolute value of negative 2v strictly less than 8. There, I want to divide both sides by 2 or multiply by 1/2. Actually, I want to divide by negative 2. Or do I? No, positive 2 because it's inside the absolute value. Divide by 2. So you get 1/2 absolute value negative 2v less than 8/2, which is 4. And now you're going negative 2v/2 less than 4. The 2's cancel, and the absolute value of negative v is the same thing as the absolute value of v. So there, the minus sign really was just a smoke screen. But now let's really do something with a negative on the outside of the absolute value. How about this? Here we really might want to multiply both sides by -1. So that we have plus absolute value of v plus 2 and -3 on the other side. And then the important thing is we need to reverse the inequality. So the less than becomes greater than. Which brings me to a new topic, and that's actually in the module as well. Sometimes inequalities have no solution. Sometimes inequalities have every number as solution, because an absolute value is always greater or equal to 0. This inequality has every number as solution. All numbers as an interval, you could write -infinity to +infinity. With infinity, you always want to make it open intervals. It indicates the numbers go on forever, they never stop, but infinity itself is not a regular number, so we want to exclude that. Another example, how about we do negative absolute value of v minus 1 is greater than 5. Multiply both sides by -1. You get absolute value of v minus 1 and a -5. And the greater than becomes less than. And this inequality has no solution. Now those two special cases, they can totally happen. If there's only one problem with inequalities, then that's kind of weird to put something like that in. But if there's multiple problems, it's quite possible that you see something where the solution is no solution or all numbers are solutions. Okay, this deals with all the absolute value inequalities that you're going to see in that module. But I've got a second video to look at the graphical side of this more. So let's pause it here.